Hello everyone, my name is Utkarsh Goyal and today I will be presenting about the topic NoSQL. SQL refers to Structured Query Language. SQL is a programming language for storing and processing information in relational database. A relational database stores information in tabular form with rows and columns representing different data attributes and various relationships between the data values. You can also use SQL statement to store, update, remove, search, retrieve information in database. You can also use the SQL to maintain and optimize the database performance. Structured Query Language or SQL is a popular query language that is frequently used in all types of application, data analytics, and developer learn and use SQL because it integrates well with different programming language. For example, they can embed SQL query with the Java programming language to build high performance and data processing application with major SQL database system such as Oracle or MS SQL Server. SQL is also fairly easy to learn as it uses common English words in its statement. So now that we have learned about SQL, let us move forward and understand about NoSQL. What is NoSQL? NoSQL databases are non-relational databases that store and retrieve data in ways that differ from traditional relational databases. Unlike SQL databases, NoSQL databases do not use tables, rows, and columns to organize and store data. Instead, they use a variety of data models and structures that are optimized for specific use cases. NoSQL databases were created to address the limitation of traditional SQL databases, which struggle to handle the massive amount of unstructured data that are generated by the modern application and system. NoSQL databases are designed to be highly scalable, flexible, performant, making them ideal for big data applications and real-time processing. NoSQL stands for not only SQL. This term was redefined by Eric Evans after Carlos Strozzi. Class of non-relational data storage system. It do not require a fixed table schema, nor do they need concepts of joins. Relaxation of one or more asset properties using CAP theorem. What is the need of NoSQL? With the explosion of social media sites like Twitter, Facebook, and Google, although Google is not a social media site, it generates a large amount of data. Rise of cloud-based solutions such as Amazon S3, just as moving towards a dynamically typed language like Ruby and Groovy, a shift to dynamically typed data with frequent schema changes. Expansion of open source community. NoSQL is more acceptable to a client now than a year ago. So due to all these reasons, we use NoSQL. So now there are four types of NoSQL. First is key value pair based NoSQL. Second is document based NoSQL. Third is column based NoSQL. And fourth is graph based NoSQL. So let us look at the first type of NoSQL. Key value paired. Key value stores a simplest form of NoSQL database where each data item is stored as a key value pair. The data is stored in a schema-less way, which makes it easy to scale and store volume of data. Key value stores are optimized for fast read and write operation, making them ideal for caching and session management. Designed for processing dictionaries. Dictionaries contain a collection of records having fields containing data. Records are stored and retrieved using a key that uniquely identifies the record and used to quickly find the data within the database. So what it says here basically means that we have a set of values and we have some keys which are given or assigned to them. And through this pair of key and value, we can access the data in the database very quickly. And so this is named as key value pair. The examples of this type of NoSQL databases are CouchDB, Oracle NoSQL database, and RAG. Also, we use it for storing session information, user profile, preferences, shopping cart data. We would avoid it when we need to query data having relationship between entities. Document-based NoSQL. Document databases store data in semi-structured format, usually in JSON or XML documents. Each document can have uniquely structured and do not require a predefined schema. This flexibility allows for easy scalability and adaptability to changing the data. The database stores and retrieves documents. It stores document in the value part of the key value store. Self-describing hierarchical tree data structure consists of maps, collections, scalar values. Examples are Lotus Notes, MongoDB, CouchDB, OrientDB, RavenDB. We use document-based NoSQL databases for management system, logging platforms, web analytics, real-time analysis, e-commerce applications. We avoid it for the system that needs complex transactions span multiple operation or queries against varying aggregate structure. The third one is column-based. Column family stores a type of NoSQL database that stores data in the column families rather than tables. They are optimized for reading large amount of data, making them ideal for a big data application. It stores data in column families containing rows that have many columns associated with a row key. Each row can have different columns. Column families are group of related data that is accessed together. Example, Cassandra, HBase, Hypertable, and Amazon DynamoDB. We use it for content management system, logging platform, log aggregation. We would avoid it for systems that are in early development, changing query patterns. Graph-based. A graph database is a type of NoSQL database that uses graph structure to store, map, and query the data. It is designed to handle complex relationship between data points and is ideal for use cases that involve large amount of complex data. Store entities and a relationship between these entities as nodes and the edge of a graph respectively. Entities have properties. Traversing the relationship is very fast as relationship between nodes is not calculated at query time but is actually persisted as a relationship. Example of these are Neo4j, Infinite Graph, OrientDB, FlockDB. It is well suited for connected data such as social networks, spatial data, routing information for goods and supplies. So now we arrive at the CAP theorem. According to Eric Brewer, a distributed system has three properties: consistency, availability, partition. We have at most two of these three properties for any shared data system. To scale out, we have to partition. It leaves a choice between consistency and availability. In almost all cases, we would choose availability over consistency. Everyone who builds a big application builds them on CAP, like Google, Yahoo, Facebook, Amazon, or eBay. So as we can see in the diagram as well, it depicts that we cannot have all three properties at the same time. At most, we can have only two properties at the same time, either consistency or availability or partitioning. What are the advantages of NoSQL? NoSQL is cheap and easy to implement as it is open source. Data is replicated to multiple nodes, therefore identical and fault tolerant, and can be partitioned. When the data is written, the latest version is on at least one node and then replicated to other node. No single point of failure. It is easy to distribute data. It does not require a schema. What is not provided by NoSQL? The NoSQL do not provide the facility of joins. It do not provide the facility of group by. All the asset transactions are not available. It is not SQL friendly. And the integration of applications that are based on SQL is not available in NoSQL. NoSQL versus SQL. NoSQL databases are non-relational databases that store and manage large volume of unstructured and semi-structured data. They are designed to be highly scalable, flexible, and performant, making them ideal for use cases where data is constantly changing and needs to be processed quickly. While SQL databases are relational databases that store data in their tables with the predefined schemas, they are ideal for use case when the data is well structured and consistent and where the relationship between the data are clearly defined. SQL databases are highly reliable and offer strong data consistency guarantees but can be less flexible and scalable than NoSQL databases. What are the use cases of NoSQL? Big data. NoSQL databases are designed to handle large amount of unstructured and semi-structured data. This can make them ideal for big data use case such as social media analytics, log file analytics, and real-time data processing. Scalability. NoSQL are highly scalable and can handle large amount of data and traffic. This makes them an ideal choice for high traffic web application, e-commerce site, and other applications that require fast and reliable performance. Real-time application. NoSQL database are designed to handle real-time data processing and analysis. This makes them ideal for applications that require real-time data such as financial trading, online gaming, and social media monitoring. In conclusion, I would like to say we are entering an era of polyglot persistence, a technique that uses different data storage technologies to handle varying data storage needs. It can also apply across an enterprise or within an individual application. All choices provided by the rise of NoSQL databases does not mean that the demise of RDBMS databases as relational databases are a powerful tool too. Thank you.